All right, pre-cal, here is case number 3. The denominator has a quadratic factor or factors. You can find this on page 806 in your book as well. Here is our example. So step 1, the setup. The setup is essentially the same. We're still using A, B, and C, but when we have a prime quadratic factor, we have to do a different setup. Remember, we always want to try to factor our denominators if possible. And as you can see here, there are no factors of 2 that add up to 1. So nothing's going away here. Okay, so take a look over here because this is the big idea for this video. This is a quadratic factor, which means it has a degree 2. Therefore, our numerator has to be linear. Our numerator is now 1 degree less than the denominator. That's the big idea, and that's what you need to carry away from this particular case study in this video. So, this problem we're going to work out along with you. So step 2, we want to eliminate the denominators just like we've been doing. And to do that, you still use the LCD. So the LCD is what we have, and we multiply both of these together. So obviously, if we have a over x plus 3, it's missing the quadratic factor, so we multiply top and bottom. Bx plus c over x squared plus x plus 2 is missing the linear factor, so we multiply top and bottom. So when we do that, that allows us to eliminate the denominators completely. Okay, so let's simplify and organize our information. So here goes. So we're keeping the left-hand side as is, and then we are going to distribute the a and get ax squared plus ax plus 2a. And here we need to use the distributive property twice, or the FOIL method, which will give us bx squared plus 3bx plus cx plus 3c. So now we're going to organize the terms on the right. So there's an x squared, there's an x squared. Here is an x, here is an x, here is an x. And then we also have some constants. Constant, constant. So use the commutative property, put together the terms that go together. 8x squared plus 12x minus 20, and that's equal to x squared times a plus b. Those are the terms in yellow. And then we've got plus x, okay, now the pink one, so that's positive a plus 3b plus c, and then the constants, 2a plus 3c. So now we're ready to start setting up our system. So remember, this is the quadratic term on the left. This is the quadratic term on the right. This is the linear term on the left. This is the linear term on the right. And then finally, here's the constant on the left. Here's the constant on the right. So that is going to allow us to set up our system and then solve for A, B, and C. So A plus B is equal to 8. A plus 3b plus c is equal to 12. And then 2a plus 3c is equal to negative 20. So there's our system. There's our system set up from the equation in step 3. Now we need to make a plan. So this equation is missing c. This equation is missing b. So it would make sense that maybe we need to solve this equation for a in terms of b. So a equals 8 minus b. And sometimes this whole planning phase just takes a little bit of massaging, so you just have to think about it. So this is a in terms of b. And over here, or let's go ahead and solve it the other way. B in terms of a would be 8 minus, or b equals 8 minus a. So this is just giving us options of what we can plug in different places. So if we solve this one, we can solve this one for a in terms of c, or how about we go ahead and just use this? Let's plug this one in here. 2 times a. The reason I'm not solving for a or c over here is that it's going to make a fraction. So let's just avoid that for a few minutes if possible. So a is 8 minus b plus 3c equals negative 20. So now we've got 16 minus 2b plus 3c equals negative 20. So negative 2b plus 3c equals negative 36. So we still can't solve for b or c without getting a fraction. So let's use this one more time and let's work on this first equation. So it makes sense to maybe take that value for a and plug it in right there, and then we'll have this fully in terms of b and c as well. So a, which is 8 minus b, plus 3b plus c equals 12. So 8 from the 12, this is going to be 4 on the other side. And then negative b plus 3b is 2b plus c equals 4. Now we've got some equations that we can really deal with a lot more easily. So first of all, this is only in terms of b and c. This is only in terms of b and c. But we can very easily solve for that c. c equals 4 minus 2b. And now we can make a substitution there, which is going to allow us to solve for b. So 2b plus 3 times c equals negative 36. Keep going, use the distributive property. Negative 2b plus 12 minus 6b equals negative 36. Try to pay as close attention as you can to signs because you don't want to make that careless mistake. Combine like terms, that's negative 8b plus 12 equals negative 36. Negative 8b equals negative 48. b is 6. There's our b. Let's take that b value, let's plug it in here, let's solve for c. c equals 4 minus 2 times b. b is 6. c equals 4 minus 12. c equals negative 8. There's our b, there's our c. We can take our b value and plug it right back in here and solve for a. a equals 8 minus b. b is 6. a is equal to 2. There's a, there's b, there's c. Let's go all the way back to the first part of the problem, which was writing out the expansion, a over x plus 3, bx plus c over x squared plus x plus 2. So our last step, step 5, is to write the partial fractions. Partial fraction decomposed. So it was a, which is 2 over x plus 3, plus bx plus c, so c is negative, so 6x minus 8 over that quadratic factor, sorry you can't see it, that's x squared plus x plus 2. So this is our answer right here, writing out the partial fraction decomposed. 2 over x plus 3, 6x minus 8 over the quadratic factor x squared plus x plus 2. That's case 3.